Good morning, students. Let us understand classification of organic compound. So organic compounds are broadly classified into two types, aliphatic compounds and cyclic or ring compound. So aliphatic compounds means open chain carbon compounds are called as aliphatic compounds. Open chain carbon compounds are called as aliphatic compounds, and closed chain compounds are called as cyclic or ring compounds. Next, aliphatic compounds are again classified into two types, saturated compounds and unsaturated compounds. So saturated compounds, the open chain carbon compounds contains carbon-carbon single bond. Unsaturated compounds, the open chain carbon compound contains carbon-carbon double bond and carbon-carbon triple bond. If the carbon-carbon single bond is present, okay, CH3 single bond CH3, carbon-carbon single bond is present, then those compounds are called as alkanes. If the carbon-carbon double bond is present, those compounds are called as alkenes. If the carbon-carbon triple bond is present, then those compounds are called as alkynes. Okay. So next, the general formula for the alkenes is CnH2n plus 2. CnH2n plus 2. So this general formula can be used to calculate the number of hydrogen atom present in the molecule. Next, the general formula for the alkene is CnH2n. Okay, CnH2n, that's it. Next, alkynes, the general formula for the alkynes is CnH2n minus 2. CnH2n minus 2 is the general formula for the alkynes. These formulas are used to calculate the number of hydrogen atom present in the molecule. Next, cyclic or ring compounds can be classified into two types, homocyclic compounds and heterocyclic compounds. Okay, so homocyclic compounds, the ring which contains only carbon atom, homocyclic compounds. Okay, so the ring compounds which contains only carbon atom, so those compounds are called as homocyclic compounds. Heterocyclic compounds, the ring which contains one of the heteroatom in the ring. Okay, so one of the foreign atom is present in the ring, so those compounds are called as heterocyclic compound. So heteroatom or foreign atom may be the nitrogen, oxygen, sulfur, phosphorus, halogen, etc. Okay, so other than carbon atom, if any foreign atom is present in the ring, so those compounds are called as heterocyclic compounds. So again, heterocyclic compounds are classified into two types. Okay, alicyclic compounds and aromatic compounds, and homocyclic compounds are again classified into two types, alicyclic compounds and aromatic compounds. So homocyclic, alicyclic compounds, so these compounds, in this, the ring which contains only carbon atom. Okay, so this ring contains only 3 carbon atom. This corner, each corner represent the 1 carbon atom. So this ring contains 3 carbon atom, 1, 2, 3. So this ring is called as cyclopropane. Cyclopropane which contains only carbon atom. So therefore this is considered as a alicyclic compound. And this ring also. Okay, so this ring contains 6 carbon atoms. This ring contains 6 carbon atoms. So each corner represent each carbon atom. So therefore this 6-membered ring is called as cyclohexane. Okay, so this is also a 6-membered ring, but one double bond is present. Therefore it is called as cyclohexene. Okay, double bond is present, then we have to add ene. Okay, so therefore the name of the compound is cyclohexene. Next, aromatic compound is again classified into two types, benzonaide compounds and non-benzonaide compounds. So aromatic compounds means it is unsaturated compounds which contains the benzene ring. Those are called as aromatic compound, the compound which contains the benzene ring. Okay, so those are called as aromatic compounds. The aromatic compounds are again classified into benzonaide compound and non-benzonaide compound. Next, heterocyclic compounds are again classified into alicyclic compounds and aromatic compounds. So let us see what is benzonaide compounds and non-benzonaide compounds. So benzonaide compounds which contains benzene ring, the compounds which contains benzene ring are called as benzonaide compounds. So this is the structure for the benzene. and this is the structure for naphthalene. This is the structure for naphthalene. So these compounds contain benzene rings. Next, non-benzonaide compounds, they do not contain benzene ring, but they have the property similar to the benzene ring, but the structure is do not shows the benzene ring. So therefore these compounds are called as non-benzonaide compounds. So this example is trophone. Trophone is the example for non-benzonaide compound. Next, heterocyclic compounds. Heterocyclic compounds are classified into two types, alicyclic compounds and aromatic compounds. So alicyclic compounds, okay, so alicyclic compounds, so which the ring which contains one of the heteroatom. So this ring, so this corner atom indicates carbon atom, and one of the carbon atom is replaced by the nitrogen. Here in this ring, one of the carbon atom is replaced by the nitrogen. Then this compound is called as pyrrolidine. Okay, pyrrolidine. If the 6-membered ring in which one of the carbon atom is replaced by the nitrogen, then this is called as piperidine. Okay, piperidine. If the 5-membered ring where one of the carbon is replaced by the oxygen, then this compound is called as tetrahydrofuran, THF, tetrahydrofuran. Okay. Next, aromatic heterocyclic compounds are classified. Aromatic heterocyclic compounds. Okay, so example is furan. Okay, so these are aromatic in nature. Aromatic in nature. They have the property resembles to the benzene ring. So therefore this is called as aromatic heterocyclic compound, and it has the example furan. Okay, so furan, where the one of the carbon atom is replaced by the oxygen, and this is thiophene, one of the carbon atom is replaced by the sulfur, and pyridine. Okay, so pyridine, where one of the carbon atom is replaced by the nitrogen. So these are the classification of organic compounds. Thank you.